So good morning student. We are going to discuss chapter number 3 of class 11th physics, that is motion in a straight line. So we discuss about the rest and motion, and when an object moving on a straight path, that is called motion of that object in a straight line. So now we are going to discuss the graphical representation of motion. What is the meaning of graphical representation? When two quantities that are dependent on each other and we want to show their relation in the form of picture or graph. So the pictorial representation of two quantities which are related to each other. So what is the graph? So motion के फॉर्म में हम ग्राफ को बोलेंगे that is pictorial representation of the relation between two quantities. We draw a picture and gives the relation between two quantities which are related to each other. So in physics, in motion in a straight line, we are going to relate displacement and time, and velocity and time, acceleration and time. So these are the physical quantities which we want to relate it with time. So graphical representation, generally the question asked in the graphical representation is that to draw a graph. So if there are, suppose we take an example, there are two quantities that are given in the form of table. The quantity is time and displacement. Here x is displacement in meter and time in second. Suppose an object moving on a straight road and the motion is represented in the form of table. Suppose after 1 second the object covers 5 meter and after 2 seconds it covers 10 meter. After 3 seconds it covers 15 meter and after 4 seconds it covers 25 meter. So we have to draw a graph between time and displacement. So suppose we have to draw a graph and we take another, after 5 seconds it goes to 10 meter. So we take two axes, this is y axis, this is x axis. On x axis we take time t and on y axis we take displacement x. So first of all we scale time axis and displacement axis. So this is origin, that is it represented 0, and this is scale the time and displacement according to the given values. So the time is given 1, 2, 3, 4, that's it. So we can represent 1 second, 2 second, 3 second, 4 second and 5 second. Time we can take time in second. Okay, but the displacement is given in the multiple of 5, 10, 15, 25. So we can scale the displacement axis as a gap of 5. So this is 5, 10, 15, 20 and 25. The maximum value of displacement is 25. So we take the gap such that we are going to equal gaps up to 25. So first of all, after 1 second, 1 second is here, after 1 second the displacement of the object is 5 meter. So this is the point. After 1 second the displacement is 5 meter, and after 2 seconds the displacement is 10. So this is the second point. After 3 seconds the displacement is 15. So here is the third point. After 3 seconds the displacement is 15 meter. After 4 the displacement is 25. So after 4 seconds the displacement becomes 25. and after 5 seconds the displacement becomes 10. So after 5, at 5 seconds the displacement of the object is 10 meter. So we draw a straight line to meet these points. So using a scale we draw the straight line, that meet these points, and this is the graph of an object which are starting from the 0 second. So there are two types of question from the topic of graph. First of all, the data is given, the time and displacement is given in the form of table, and the question is to draw a graph from these data. And in competitive exams, one types of questions ask that the graph is given, and question asks that what is displacement of an object at 4 seconds. So these kind of questions also asked. So answer is, the time 4 seconds is here. At 4 seconds the displacement is 25. The table is not given, only graph is given, and the question asked about the data. Okay, at 4 seconds what is the displacement of the object? So answer is, so we take the time is given, so at 4 seconds the displacement is 25. So answer is 25 meter. Another types of question, at which time the displacement of object is 10 meter. At which time the displacement of object is 10 meter. Here the displacement is given, so the 10 meter, and at which time the displacement, so this is the graph, or at which time it is 10, so this is the time, and this is, so at 2 second and at 5 second, 2 second and 5 second. So answer is, at 2 second and 5 second the displacement of the object is 10 meter. So there are two kind of questions can be asked in examination. First question is, the table is given and examiner asks to draw a graph between these two quantities. Okay, and if the graph is given, the examiner asks about the data from the graph. So you have to prepare both types of questions. So in physics or in motion we study about mainly three types of graph: displacement and time graph, velocity and time graph, and acceleration and time graph. So first of all we have to discuss about the displacement time graph or position time graph. So we can take, so first of all, position time graph. Position time graph or displacement time graph, because we represent displacement by x and time to t, so it is also called xt graph. The another name of position time graph is xt graph. So from the name it is clear, then we take time on one axis and displacement on another axis. So in position time graph we take time on x-axis and displacement on y-axis. So we have to relate these two quantity according to the motion of the object. So there are different types of position time graph. So first, when object is at rest. Okay, this is the time axis and this is displacement axis. So displacement and time. So if the graph between displacement and time is a straight line parallel to time axis. So what kind of graph is there? Straight line parallel to time axis. If the graph is drawn in the form of a straight line that are parallel to time axis, that means the object is at rest. Why? At 0 second, suppose the displacement is 10 meter. The displacement of the object is 10 meter. After 2 seconds, the displacement is 10 meter again. After 4 seconds, the displacement is same. After 6 seconds, the displacement is same. Suppose this duster is placed 10 meter away from me. So if at 2 seconds the displacement of duster from me is 10 meter. If duster is not moving, then the displacement remain 10 meter. So we can say that the duster is at rest with respect to me, with respect to surrounding. So a straight line parallel to time axis represent the object is at rest. So it represents the object is at rest. Graph number 2. Moving with uniform velocity. Okay, if we draw the graph between displacement and time, we are talking about the velocity. If the graph is between distance and time, we talking about the speed, uniform speed. So here we take displacement and time graph. So uniform velocity. What is the meaning of uniform velocity? We discussed in the previous lecture that if an object covers equal distance in equal interval of time, then the motion of that object is called uniform. So if an object moving with the uniform velocity, the graph between time and displacement of the motion of that object is a straight line but not parallel to time axis. The straight line with a slope. So what kind of graph is this? Straight line with slope. So this is a straight line also, but it is not parallel to time axis. The straight line with a slope. So the straight line in the xt graph represent the object is moving with the uniform velocity. How? We take 1 second interval, 1, 2, 3, 4. Okay. What is uniform? What is the meaning of uniform velocity? If an object cover equal displacement in equal time interval. So this is equal time interval, 1 second. Or this is displacement. So after 1 second the displacement is 5. After 2 seconds the displacement is 10. After 3 seconds the displacement is 15. After 4 seconds the displacement is 20. So this kind of 5, 10, 15 and 20. So first 1 second, after first 1 second the object covered 5 meter. In next 1 second the object cover 5 meter. Next 1 second object cover 5 meter. So object covers equal displacement in equal time interval. So this kind of motion is called uniform motion, or an object moving with a uniform velocity. Another kind of graph is if the graph is curved. This is a straight line, this is a straight line. This is a straight line parallel to time axis. This is a straight line with a slope. But if the graph is curved, then what types of motion it represent? If the graph is a straight line parallel to time axis, it represents the object is at rest. If a graph represent with a straight line with a slope, it represents the motion of an object with uniform velocity. But if the graph is curved, and what kind of motion is represented by a curved graph between displacement and time? When object moving with non-uniform velocity. If an object moving with the non-uniform velocity, the graph is curved. Any type of curve between the x and t. So if the graph is like this, so this is the displacement and time. So we can say that first 1 second the displacement is 10 meter, but next, this is equal graph, so next 1 second the displacement is only the object does not cover equal distance in equal time interval, because first 1 second it covers 10 meter, in next 1 second it covers only 5 meter. So this kind of motion of that object is called the object is moving with the non-uniform velocity. A curved graph between displacement and time is represent the motion of the object with a non-uniform velocity, or we can say that this is the accelerated motion. If the velocity is changed with respect to time, the change in velocity with respect to time is called acceleration. So this kind of motion is also called accelerated motion. Here the velocity is changes. Here velocity is same every time, because velocity is displacement upon time. So what is the displacement? 5 upon time 1. So what is the velocity? 5 meter per second. Time of 2 seconds. So in 2 seconds the displacement is 10. So 10 upon 2. 5 meter per second. So everywhere if we calculate the velocity, displacement upon time, it is always remain 5 meter per second. But here the velocity of that object does not remain same throughout the motion. So the velocity is changed. So if the velocity is changed with respect to time, then these types of motion is called accelerated motion or non-uniform motion. So there are 3 types of xt graph. When the object is at rest, when object moving with a uniform velocity, and object moving with a non-uniform velocity or accelerated motion.